Hi everyone, my name is Fabien Ruffin. I'm a tech director at the Domain Group, and today I'm here to talk to you about serverless continuous delivery with the serverless framework. Is that what you're here to listen to? Yeah? All right. Before we start, do you mind if I take a selfie with you guys? Yeah? It's all good? There we go. Awesome. All right, now we can go with the real stuff. Cool. So before we get started, who has used the serverless framework before? Show of hands. A few people. Okay, cool. Are you more AWS people or Azure people? A bit of a mix. That's good. Google, anyone? Okay, cool. So I'll try to make it as relevant as possible for all of you. But first, so yeah, what is serverless computing? So more often than not, when we think serverless, we think about function as a service. So that would be Lambda on AWS, Azure Function, and yeah, I don't know for the other providers. I'll stick with those two. But yeah, there is actually much more to it than that. So for the other examples, storage can be serverless as well, like Amazon S3 or Azure Blob Storage. By the way, this is how I see S3 and Blob Storage working, a bunch of floppy disks. Databases like DynamoDB or Cosmos DB as well. And so again, that's going to scale with your needs. You don't have to worry about what kind of servers you're going to have behind the scene. And also then on the messaging side, so with AWS SQS or Azure Queues, all those kind of things. So all that is really serverless. It's not just the functions. So yeah, so my screenshots and demos are going to be with AWS, but yeah, the concepts are the same everywhere. So yeah, this is what it looks like in the AWS world. So we're looking at one of my functions here. It has an input, which is going to be API gateway. So essentially just meaning that we're going to be responding to HTTP calls. That's one of the dependencies, CloudWatch, which is just for the logs. We're picking the runtime, which is going to be Node.js 6 in this case. Then we write some code. What it is doesn't matter. It doesn't need you don't need to read that. And then in the end, our configurations. So in the form of environment variables. So that could be, I don't know, like database connection strings or API keys for things. Okay, so this is great. It's easy to get started. You can do it straight from the console. That's the same on the Azure side. You can do it straight from the console, but really, it's not ideal. So where it all falls apart for me, I think, is first, there's not really any source control here. How do you run your tests? How do you run it locally to make sure that it works first? Or how would you debug it to make sure that it works? No version history, so how do you roll it back? If, let's say, you save your function, a new version of your code goes live, but then, yeah, for some reason it's not quite working, how do you roll back? How do you know exactly what was there? Or maybe another dev is going to be pushing a new version of it, missing some of your changes. So how do you deal with that? There is no naming or tagging convention. So yeah, it's up to you to name your functions the way you want. And if you've got an application with, let's say, 10 functions, yeah, they could have 10 completely different names and you don't know that they're even related. No logging by default. And more importantly, it's not easily repeatable. So once you got it all working for dev, how do you make it work for staging and then for production? How do you make sure that you're not missing this little tick box that you've ticked on in your dev environment? So there are other tools that's provided by either Microsoft or by Amazon to do this from your IDE of choice. So yes, for example, for me, I'm a C# guy at heart, so I would do it with Visual Studio. That would be right-click on the project and publish, and then. But we've got very much the same problem here. What guarantees that we've got the last version of the code? The latest version of the code. And one wise man said one day, friends don't let friends right-click publish. So yeah, what he meant there is don't do this, because then again, you never know that the tests have run, and you never know that you're going to be shipping good quality to production. So luckily, there is the serverless framework and a few other tools, but we're going to be focusing on the serverless framework to help with that. So yeah, a few people raised their hand. So a few people know already what this is, but the serverless framework is there to help, yeah, making sense of all of this and adding a little bit of structure to this crazy world, really. So it is written in Node.js, and yeah, it's a suite of tools to orchestrate your deployments. It is available on for a lot of different providers. So this is kind of cool, really. So you can imagine your code written for for AWS, but then with a few changes, deploy small changes, you can deploy that to Azure or GCP or any of those providers. So yeah, this is really a good solution in my opinion. So the way it works is that it's based on so again, focusing on the AWS side here, it is based on CloudFormation, which is the templating engine, I guess, for AWS. So that means that the Lambda functions are going to be all in that template, as well as the triggers. So that would be API gateway in the case of AWS as well, or that could be any other trigger, really. But the cool thing as well is that it doesn't have to stop at the function and the event for it. If your application's got dependencies, let's say on a database, so DynamoDB or Cosmos DB, you can also declare it there and deploy everything as a package, which is very, very nice. It's got configuration management built in, so again, when you try to deploy between multiple environments, you can manage those the small variants here directly, which is going to be very cool. We'll see how that works. Local execution, so you can run the code that would run on Lambda or Azure Functions locally and debug it properly without having to just deploy every time and make sure that it works. Unit tests can be part of your continuous integration pipeline. And more importantly, because everything is done from the command line, you can automate the hell out of it. So yeah, we're going to look at how we can do some of this. All right, demo time, I guess. And I've cheated a little bit. Everything is pre-recorded. So the demo is going to be based on a website called Serverless Stack. So this is a tutorial on how to use serverless and build APIs and front-end client apps. If you're not very familiar with the serverless framework, I would recommend that you go through this. We're going to go through the simple application in a minute. So yeah, that's where it is. I'll have the URL up at the end as well. Cool. So that's what the application looks like. So this is just a note-taking app. So yeah, it's got authentication built in as well, using Cognito. Then you've got a list of notes. I can add a new note here and add attachments. So I'm going to add a picture here and click Create. So it's added to my list, and then of course I can reopen my notes and my attachments. So this is great. So that's the architecture of the application. So there are actually two applications, an API and a website. So on the API side, we just have a Lambda function, a bunch of Lambda functions actually. There's more than one, with API gateway on top to basically serve the HTTP request and hand that over to Lambda. And behind the scene, the notes are stored in DynamoDB, and the attachments, so the photos, in S3. So this is it for the API. And on the other side, for everything runs client-side. So this is just static files in S3 with CloudFront as a CDN on top of it. Now, the block on the side over here, Cognito, this is the part that is dealing with identity. So that's the equivalent of your Azure AD if you're on Azure. So that is also we're also going to deploy and provision this part with serverless. So this is the part we're going to look at after this time, the API and Cognito. We're not going to worry too much about the static website because, well, there isn't much to worry about here anyway. Cool. So let's look at the basics. Can everyone see this? I hope that works at the back. So this is our little app, and this file here, the serverless.yaml file, is really at the core of what the serverless framework is. Everything is managed from here. So yeah, that's the file over there. First things first, you need to give your application a name, and that name is going to be used to infer the name of all the other resources that are going to be created as part of your project. So this is really important to get it right, and it's really important to not change it, otherwise it's going to recreate a complete new stack. Then you specify your provider, in my case AWS here, and the runtime, NodeJs. And then very quickly you get to this kind of options where everything is built in. So logging, for example, is built in. So whatever you write to the console is going to get into your logs, and you decide here how long your logs are going to be retained. And then tagging, I forgot to mention before, is also important and can be done here. So if you've got a fairly big company or a big AWS account or Azure account that you're running, you most likely have hundreds of resources in it, and it's sometimes hard to know what is used for what and how much it costs and all this kind of stuff. So tagging helps with that to identify which application it's part of. So again, here we're going to have consistent tagging across all our resources, which is great. Going a little bit further down, we've got there are a bunch of plugins as well that you can install for serverless to do various different things. So here I've got 2 installed, one for Webpack to sort of put together the application, and you can. So here it's mostly to do to transpile the code to ES6, but you can do things like Uglify as well to make sure that your code is going to be as small as possible to make sure that it starts as quickly as possible. And the other plugin I've got installed here is Serverless Offline, which is sort of an emulator for API Gateway in a way, so I can really test the whole thing locally. The next 2 bits I'm going to go very quickly over because, I'm going to get deeper into this later. You can have, that's for the configuration management. We'll get to that later, but it's referenced from here, so it's referencing another file. And here, that's how we reference all our external resources, but we'll get back to that. Cool. Going a little bit further down, that's finally the important part, where we're going to declare our function. So in a node-taking application, I've got a function to create a new node, right? And that's what this declaration is here. So first, there is the handler. So that's just pointing to the create module over there and telling it that it's to run the main function. A little bit lower, we've got the events. So in this case here, this is going to be an API, so an HTTP event. So that's going to tell serverless that it has to provision an API gateway. And then after that, the path of that API. So that's going to be for this to reach this function, we're going to have to do a post on our API, and that's going to be under the nodes endpoint. And yeah, there the other 5 functions are down there, but yeah, there is not really any new point looking at them. So then after that, we can call serverless package to just put everything together. It's going to take a little while, but here it's running Webpack to do its thing, and yeah, depending how you've configured Webpack. And after that, it's going to start looking at your configuration, your serverless project, and put together a CloudFormation template, which we'll look at in a minute. All right, so that's done. So it has created a .serverless folder at the top with the CloudFormation template here. If I do a search for function, I can see the create function that we're just looking at before. It's here with all the default attributes over there, the runtime, the timeouts, the tags, and very important, the environment variables as well. But we'll get back to that a little bit later. If I look for API Gateway, I can see that my API Gateway has been created as well. Don't worry too much about the details, but yeah, it's here. And the next thing that has been created as well over there is a zip file, which just contains all our source code. So that's going to get uploaded to S3 later on, and that's for Lambda to look at. But we'll worry about this when we do our deployment. So yeah, so like I was saying before, serverless is really going to do a lot of the heavy lifting for our continuous integration and continuous delivery pipeline. So we can manage our dependencies from here. So that's, in the case of our application, that would be our DynamoDB table and our S3 bucket and our Cognito user pool and identity pool. So this, where are we going? Here, so that we're back in the serverless YAML file, and remember at the beginning I was showing you this resource line here, and it's just pointing at another file in that conf folder over there. So let's have a look at it. So there isn't much in it. I'm just so looking at this file here, resources.yaml. I'm declaring my DynamoDB table. We're going to look in the details in a sec. My S3 bucket, and the user pool and identity pool for Cognito. So if I look at the details of the DynamoDB table, first I got the option of giving it a name. So here I've got fr-notes-, and then there is something in curly braces here saying current stage. So the different environments in serverless are called stages. And so here in this case, that means that if I try to deploy to a stage called dev, it's going to create a DynamoDB table called fr-notes-dev. If I push that to production, it's going to be fr-notes.prod. So yeah, it's very convenient to make sure you've got a really consistent environment. After that, I've got just all the different settings from for my DynamoDB table up to even the capacity that I want to provision. So yeah, just if you can see the details here, the read capacity and the write capacity are also in curly braces, meaning that we're going to inject that from our configuration later on. But yeah, we'll get back to that. Cool. Looking at S3, that's very similar. We've got just very simple settings here, but you might have noticed that I'm not actually specifying a name for it. This time I'm actually going to let CloudFormation figure it out by itself. And the way it's going to do that is going to look at the name of the template or the stack, and then use the name of the asset that which I'm calling attachments bucket here, and then add another random string at the end. So yeah, you don't have to deal with those things yourself and make sure that you manage all the names yourself. You can let CloudFormation deal with that. Cool, and then yeah, Cognito is very much the same, not really worth looking at just yet. Okay, another thing that is quite powerful as well with the approach of deploying everything through a big template like that is that we can tweak the permissions that our functions are going to have. So by default on the AWS side, you have to create an IAM role for this, saying, hey, you can use this resource, you can use that one, you can use that one. Well, all that can be managed by Serverless as well, and that's what this file is about here. Again, it's referenced from the main Serverless YAML file. And what I'm saying here is, okay, so whatever all the functions that I'm creating here are going to have all those permissions. So query, get item, put item, update item, delete item from my DynamoDB table. And here I'm referencing it directly. Cool. So yeah, so now we've got our dependencies managed. Let's have a look at the configuration management. So again, this is one of my favorite part here. That's how you're going to manage your different environments and make sure that you've got a consistent deployment across all the different environments. So again, going back to the main serverless file, there was this custom variable that we were looking at before, pointing at another file. So hang on, let's just look at it quickly. So the file is over here. And so the way it starts is that you have, for each variable that you want to expose as an environment variable, you need to, ideally, you need to declare a default value for it. So here I'm going to have only two variables, one called profile, which AWS profile to use to do the deployment, and the other one, table throughput. So that's how much capacity I'm provisioning for my DynamoDB table. So by default, just one, because it's going to be for the dev environment. And then the next section here, called stages, that's where you're going to define all the variations, really. So the top one here is called dev, so that's the name of the environment. But under it, we've got AP Southeast 2, so that's a region. So assuming that you've got an application that is global and that you have to deploy in a lot of different environments, in a lot of different regions, sorry, that's how you would handle the configuration differences as well. So yeah, so here for dev, I've got a table throughput of only 1. For staging, I've ramped that up to 5, and production to 10. Cool. Now, next step. So this one, if we go a little bit further down, this is going to get a little bit complicated, and a bit messy. So now I know what each of my environments should be, but I need to know what is the current environment. So that's what that first variable here, the current stage, is going to do. So it's going to look at if there was a stage that was passed as an argument to the command line for serverless when we run it. Otherwise, it's going to pick the default from the serverless YAML file. And then we're going to do the same with the region. So by default, it's going to pick up the Sydney region. But if there was a region provided in a serverless CLI as a command line, then it's going to use that instead. Then the clever bit here is that we're going to try to those variables can actually reference themselves. So what I'm going to do with that last line here, the M settings, I'm actually referencing the stages variable that we saw before, and then turning down to current stage and current region. So then that means that M setting in this case, so in the case of production, which we can still see, it would have those values, so profile, default, and table throughput 10. It doesn't know that it's the prod anymore, but it knows that the current environment settings are that. All right, cool. the last part of it is to just expose those values individually, so that's they're easier to reference later. So I've got this variable here, current vars, that I've declared, and there is a profile variable in there. So by default, it's going to look at environment-specific settings, and if you can't find them, fall back to the default block that we've seen at the top. So yeah, that's probably the most complicated part of it all. But yeah, it's once you start having a look at it, it actually makes a lot of sense. So if we go back to the serverless YAML file, the profile variable that we were just looking at before is then very, very easy to use. All I have to do is say current vars.profile. I don't have to worry which environment or which region I was deploying to. I know that it's going to take the current environment. So for the rest of the code, it's really, really simple. And the nice little trick here as well is that as part of, as you've seen before when we were in the AWS console, and you can manage environment variable for your function, right? So that's done with this environment variable there. So the trick here is if you do if you assign the custom vars object that we were looking at before to environment variable, it means that all the settings that we just looked at would be pushed as an environment variable. So just be very careful there, because not to put any sensitive information in there, because it's not that private, it's not that secure, and I'll show you an example of it after. Cool. So now we've got everything put together. We've got our dependencies managed. We've got our code ready, and we've got our environment, our configuration management done. So let's do our first deployment. So I'm going to go against what I said we should do and don't do publish. But anyway, we're going to do it locally and run serverless deploy. It's going to go through the same thing as before, and then it's going to upload our zip file to S3, and I guess apply the CloudFormation template. So here, that was the first deployment, so it creates a new CloudFormation stack in AWS. And then in the end, after a few minutes, I get the list of all the functions that were created and the list of all the API endpoints that were created that go with it. And yeah, that went a little bit fast, but if I scroll up a little bit, perfect timing, we still get the stack name and a little bit of information about the infrastructure that was just deployed. Cool. Let's go back to the AWS console to see what was created. So if I look at my functions now, they're all really neat and tidy. The first part of the name of each function here is the serverless, the service name that we've defined at the very, very beginning of this talk. Followed by the environment name, followed by the name of the function. So you can imagine if you got 2 or 3 environments, it's really, really easy to see what belongs to what, right? And yeah, it makes troubleshooting a little bit easier. Now, remember when I was talking about environment variables? So this is what one of the functions look like. If you drop down to environment variables, this is what we've got. They've all been pushed as expected. Even that one. So that one, if you're at the back and you can't read, it says Stripe secret key. By the way, it's not a real key, so don't try to get that quickly. It's not valid anymore. But yeah, so it's shown in clear here. So that means that if you've got access to your Lambda console, then yeah, you can see this kind of sensitive information. The other thing as well, I'm not showing it here, but if you look at the details of the CloudFormation template, you would see that the key is there in clear as well. So if anything, if you got any sensitive information, don't refer to it directly from yeah, from these things. You'll have to use something like a key management service like Amazon KMS, or what is it called on Azure? Is it Azure Vault, Key Vault? Yeah. So yeah, so one of those. So yeah, be careful. All right, going through this very quick. We're going to have plenty of time for questions. So now that we've got serverless doing all the heavy lifting, we can focus on the automation. I had plenty of choices for the CI tool. I decided to go with Visual Studio Team Services just because it's easy to provision. It's just there. And then just after I finished preparing my slide, Azure DevOps came out. So yeah, it's somewhat irrelevant already, but yeah, it should work with VSTS or TeamCD, Jenkins, whatever you're using, it works. Now, for our deployment scripts, we're actually going to rely a lot on NPM. as much as we love to hate it. NPM is actually pretty good to run this type of scripts. So yeah, if I look at the package.json file that belongs to my application, I've got a bunch of scripts here. There's one called build, which is just calling serverless package, which we've seen earlier. Then deploy, which is just calling serverless deploy. And then the last one is test, which is using a library called jest to run all my unit tests. So we're going to run that as part of our CI pipeline as well. Cool. So let's have a look at the tests. So yeah, I don't have many tests. I'm not that good a developer, so I don't write many tests. But yeah, they're here and they run. That's all you have to know at this point. Now, the problem with serverless packages, once we run the serverless package, if you remember, we've got a CloudFormation template that gets created and a zip file with our source code. So there's nothing wrong with the zip file, but packages are not reusable across environments because the CloudFormation template has environment-specific information in it, right? So it would have, for example, I guess the hard-coded name of the DynamoDB table, or environment variables that are specific to dev or to stage or production. So yeah, we're sort of kind of stuck. We've got really two options here. The first one is to package all the versions one by one as part of the build. Or the other option is to package at deployment time. So at the time you deploy, you just say, hey, I want to deploy to prod, and it's going to go repackage the prod thing and then push it, which is not ideal. So first problem with if we package all the versions at once is that it would take longer. Imagine if you got 10 environments or 10 different regions on 3 different environments. That's all of a sudden 30 builds that you have to run. Yeah, that's going to take forever. At least on the other side, the build would be fast because we just run the dev one once and to make sure that everything is okay, and then that's it. But then the flip side of this is that then if we package everything up front, we can deploy quickly. On the other side, well, we would have to rebuild, which takes a couple of minutes. But more importantly, what bothers me a little bit in terms of continuous integration is that you're meant to be reusing the same package across environments to make sure that your code is the same. So in theory it is, but can you prove it? I mean, do you know that it's always the same? Or if you want to roll back, right? Let's say you do a release, it's gold, it works fine. 3 months later, you do another release, doing an update, it doesn't quite work. You want to roll it back. When you roll it back, you're actually going to recompile your application. More importantly, NPM is going to go and fetch its dependencies again, which may or may not be around. I mean, we've all been burnt by that. So it's not great. At the end of the day, you have to make your own decision as to which option you want to use. I don't have a silver bullet on the next slide, unfortunately. Personally, I've used the other one package at deployment time for this demo, even though I prefer the other one because there is a bug in serverless right now that doesn't let me do the package all versions at once. There's a pull request for it, though. So we're going to look at running one quick build as part of continuous integration, and then rebuilding quickly as part of the deployment. How are we doing for time? Yeah, good. Cool. So because of the way we're going to be deploying, the CI pipeline is going to be a little bit backwards. We're going to start by publishing everything. Because really what the deployment is going to do is look at the source code and call deploy on it. The problem is, like, the next step is to restore NPM packages. We're going to end up with really a lot of artifacts if we've got all those thousands of files for NPM. So for this specific case, I've decided to publish the applications first, then doing the NPM install to restore our packages, NPM test to run our tests, and so that's going to fail the build in the case the test doesn't pass. And then the last step is to build the dev package. So the little trick here, you need if you're using VSTS or something else, really, you need to make sure that your build agent has access to AWS to run the CloudFormation template. So that's what this step is doing here. And my script here is just saying npm run build, and then specifying the stage of dev. So I'm forcing a dev build here. I don't really care about the output. I just want to make sure that the validation runs, that everything works fine, that I'll run ESLint so that everything is okay. Cool. So actually, going back quickly on publishing the artifacts, another way to do it would be to, once you restore your NPM packages, to create, I don't know, a zip file or a NuGet package or NPM package or something like that, that you can then host somewhere else and redistribute. So at least you've got all the dependencies packaged together. So that makes the rollback a little bit less flaky than what I mentioned before. But yeah, just to keep it simple here, just publishing the code. And yeah, so that runs. The build takes about 2 minutes, 2 minutes and 52 seconds here to do everything and run my tests. So that wasn't too bad. Now, if we look at the deployment side of things, so I'm getting my artifacts from my build. So yeah, the first step here, when we trigger this, we're going to pick the build we want to look at, obviously. And then two stages. So one to deploy to staging, and then one to deploy to production if the first deployment was successful. So again, here, that's going to be very simple. We have to do a npm install because, well, the deployment agent doesn't know about serverless at this point, right? So it can't run anything. So yeah, it's going to do reinstall serverless this way. And then all we're doing here is, again, the same as before, but running npm run deploy and specifying that the stage is staging. And it works if you run it. I'm going to save you a few minutes by not running it here, but yeah, it took only, I think, 3 minutes to run this. And we've got all our code on staging. It has also at the same time redeployed a new DynamoDB table, a new Cognito user pool, a new S3 bucket, all with different names, predictable names. And our functions are there as well. So as you can see, this is CloudFormation, so this is the templates. I've got that new one at the top here called Nodes App API Staging. And I had nothing to do really to on the AWS side to spin up this new environment, which is very nice. Cool. All right, so let's just go back to our original goals, and after that, I think I'll open up for some questions. So we said we didn't have any source control. Well, that's resolved because now we can just check in everything quickly. No automated tests. Well, we've got them with Jest. Local execution and debugging is now dealt with as well. So something I didn't show, but you can also with serverless run an individual function locally and debug through it. Just again with a simple command line. The versioning and history, like the rollbacks and all that, is now taken care of because all I need to do is to go back to Visual Studio Team Services and redeploy a previous release or do a rollback, and this is it. The naming and tagging conventions are now taken care of. Logging is set up. And the most important of all is that it's really easy to repeat across environments. So as you've seen, yeah, deploying a new staging environment was super easy. If I wanted to do prod right now, it would take just another 3 minutes, and it's of wait time really, and that would be it. So yeah, I'm a big fan of serverless and the serverless framework in particular. If you want to hear more, I would recommend checking out serverless.com. They've got lots of cool stuff. They just came up as well with a new serverless dashboard, so you can have a look at the health of your Lambda functions and how they behave over time. And then, yeah, serverless stack, which is the tutorial I was talking to you about before, if you want to learn more about serverless itself. And yes, really, really well done. So yeah, I would really recommend that you check it out. Now we still have a little bit of time. Do you guys have questions? Probably the most important part. No? Yeah?
So when you walk through the configuration phase in particular,
yeah,
using AWS as the example,
yep,
how different is that configuration structure across Azure, Google? It still follows the same
it's not very,
just the values, or is there?
It's not very different. So the core of it, and at least declaring the functions, is very, very similar, because when you think of it, the actual services are very much the same, right? So the syntax changes slightly, but they try to keep it as consistent as possible. Then obviously when you get to, when we were talking about managing dependencies and external CloudFormation templates, like the DynamoDB table and all these kind of things, that obviously won't translate really well on Azure. It won't translate at all, because it is really a pure AWS speak, right? But you can, what you could do is the way we're doing the configuration management, you could also have another one like saying, hey, if you're running in an AWS context, use this configuration these configuration files. If you're running in an Azure context, use these configuration files, and then you can still share the code and most of the infrastructure around it, I guess. Yeah. So that makes it really easy to switch providers. Yeah. Yeah.
I noticed serverless is tied to CloudFormation for AWS.
Yeah.
Is there any ability to use tools like Terraform instead? Or
I haven't tried myself. I think there is a plugin for that, but yeah, I need to double check. I'm not 100% sure. With that said, if you wanted to add support for it yourself, that's how you would do it. You can write you can write a plugin to sort of hijack the template generation and do that with Terraform or any other product. Yeah. Yep.
If I need to refresh my dev environment for production, how does it work? Do I need to write my own configuration, or is it an automatic feature?
So okay, so how do you refresh your prod environment, your dev environment from prod? So what are you trying to refresh?
Refresh the data or whatever.
Refresh the data. So yeah, that would be something separate, I guess. So here, yeah, what we will be looking at is resynchronizing S3 buckets and DynamoDB table, I guess. Yeah, you would have to do what you normally do, I guess, for your normal maintenance jobs. Yeah, yeah, it's not something that it deals with. It doesn't. You can't take a snapshot of an environment and just recreate it, unfortunately. With that said, like in the case of DynamoDB, you can now take snapshots and restore them on another table if you need to, right? So that's fairly painless.
Also, when you show us a YML page,
Yeah.
there's a lot of configuration code.
Yeah.
Is that case sensitive, especially when it comes to the environment variables, or do you get IntelliSense with that?
You don't, do you? No, you don't. And it is case sensitive, if I remember correctly. Yeah.
probably no reason you couldn't add it, right? There's, I know for the Kubernetes configuration, for example, in VS Code,
Yeah.
all sorts of IntelliSense.
Yeah, yeah.
Someone could.
Yeah, exactly. You could write your own extension for it. Again, yeah, it doesn't exist right now though. But yeah, if you wanted to write it, you can. The other thing as well, I forgot to mention. So you're right. It is a lot of code in the serverless YAML. But if you go through the serverless stack tutorial, you'll see that there are a bunch of different templates that you can use to get you started. So that would create a couple of functions and all the necessary configurations. So at least you got a functioning project within a minute or two. Really, it's really quick. Yep.
So in your demo, I saw you created a S3 bucket without any name. So when you update stack, will there be a new bucket next time? And how would
No, it won't. So I don't know how CloudFormation managed to decide what random string to put at the end, but it doesn't actually change it. Hang on, let me just show you what it looks like. Now this is the scary part. We're going to go interactive. I think that was over here. Yep. So hang on, let me just check. Let's go to S3. So hang on, can you see? Actually, no, you can't. I need to. Better, yeah. So let me just zoom in on this a little bit. So this is what it created here. So you've got nodes-app-API. So that was the name of the service. Then dash the environment. So yeah, staging in this case. Attachments bucket, that comes from the name that I gave it in the CloudFormation template. So that was not the name of the resource, but that was the sort of the logical name of the resource in the template itself. So hang on, where is it? Whoops. And this is why I recorded my demos. But yeah, so here on the resources, I've got attachments bucket. That's where it gets the name from. And then the last bit is random. But yeah, somehow it manages to not create a new one every time. It keeps track of it. So that must be a hash of the resource somehow, or the resource name or something. Yeah. Anything else? Yeah?
Is there any schema available to define the YAML file, or how do you define the attributes and these type of things you recommend?
There isn't that I know of. But if you go to docs.serverless.com, Yeah, there is. If you go, so yeah, so that's all the providers that it supports. I hate it. It does that. Let's go on the user guide.
These are predefined attributes.
Yes, yeah. Well, some of them are. Hang on, I'm just. I can't. It doesn't let me scroll down. Hang on. There. For some reason, when I scroll, the navigation goes away. So yeah, so in the documentation, there's a reference serverless YAML with all the supported functions enabled, really. So and good comments as well, so you can easily find out what all that stuff does. Yeah. So then when you go to hang on, where was it? Custom. Is it here somewhere? Because yeah, you can extend that as much as you want, obviously, and so the custom variable that we were looking at before, that is, there's no schema, there's no validation there, right? You can do whatever you want. So if we go back to, where was it? Here, the variables YAML. Hang on, let me zoom in a little bit more. So over here, you do whatever you want, really. So the convention of going with default, then the stages, then putting it back together, this is not entirely, that was just my thing. If you want to do it in a different way, go ahead. There's nothing forced. And then obviously, yeah, the profile, bucket name, table throughputs, all that I just made up as well, right? Based on what I needed. So yeah, it's really, really flexible. Actually, let's have a look, see if they've got a serverless YAML for Azure, just to see how different that would be. They don't have it here. So yeah, the comments to create the new service are just exactly the same, depending regardless of the provider you're using. I'm just looking for an example of the serverless YAML here. No, they don't seem to have it. But yeah, it's very, very similar. Ah, there we go. You see again, you've got your provider. You get the name of the provider. They don't call it region in Azure. They call it location. So then I guess you've got your region name there. But yeah, overall it's very much the same. We still get functions, the name of the function, what the handler is it what type of event, and in this case an HTTP event. Yeah. So it looks very, very much the same. Cool. Anything else? Nope. Yep.
Are you aware that AWS Lambda toolkit for Visual Studio doesn't work on top of serverless framework?
Yeah, so the Lambda toolkit for Visual Studio. So if you're writing a Lambda function that is written in C#, you still need it, because the way you're going to expose your C# classes and all that is going to be, yeah, well, you need to reference some of their SDK. But the tooling, as in the right-click publish and all that, yeah. Hang on, where's my slide about right-click publish? But yeah, so I'd say you pick one, right? So it's either you're going to deploy with serverless or you're going to do it with their tools. With that said, they've got what's it called? AWS SAM, the serverless application model, which is getting there as well, pretty mature as well for these kind of things. But it is purely AWS. That's the problem. Serverless still does a little bit of everything, and it's been around for a bit longer as well, so it does a bit more. Anything else? No? Cool. Well, in that case, thanks everyone for coming, and yeah, I hope you enjoy it.